Everybody, I'm happy that you got the time right. I see some of you are still fighting against the cold, still in your pajamas. Nah, okay, but it's time to work now. So let's quickly look at the question that we stopped with yesterday. Oh, we stopped with this one. We worked out the acceleration yesterday. That was the last one that we did. Okay, now they say the rough surface now is replaced with a smooth frictionless surface. The 2 kilogram mass piece is released and hits the ground before the 1 kilogram reach the end of the horizontal surface. Okay. Will the 1 kilogram mass piece move at a lower, higher, or zero acceleration? And explain your answer by using Newton's law of motion. Now, the 1 kilogram block, let's just go back to the picture, is the one that's on the table. And that's the one that does not have any resistance anymore. Now, in comparison to where it moved previously, it's definitely now going to move faster. It's going to have a greater acceleration. And for this reason is because now there's no resistance, there's no, friction force. And when we look at the friction force, then we know that if we work out F net in the previous sum, we said F net equals to N times A. It is the tension minus the friction. Now, if there's no friction to minus, what's going to happen to the net force? It's going to increase. Okay. So what is going to happen? 1 kilogram block is going to move faster because there's no friction to minus from the tension force. Therefore, the net force will increase. Okay. It counted, this one counted, let me just see, 2 marks. So it is important that you say that it's going to increase in acceleration. That's number 1. So if they increase in acceleration, that's 1 mark. And for the next mark is to explain that the net force will increase. Either by using, if there's no net force, no friction force, the net force will increase, or by using, and now we are using Newton's second law, which says F net equals to m times a. And this is what they meant by using Newton's law to explain this. Now, if the acceleration increase, the net force will increase. And that is what I did here in the previous slide, if I can quickly go back. So force is directly proportional to acceleration. Okay, so for one acceleration, and there is no friction force anymore, acceleration increase. Why? If the acceleration increase, the net force will increase as well. Okay, the next question that we're going to do now is 3. That's the one that we just did, 3.2. A man with a mass of 60 kilograms skis from rest down a straight slope that makes an angle of 15 degrees with the horizontal. The slope is 75 meters long. He reached the end of the slope with a velocity of 15 meters per second. A constant friction force is working on the skis as he moved down the slope. Write down the equation of the magnitude of the normal force working on the skier and determine the magnitude of the normal force. Actually, this question can just be determine the normal force on the skier. Now, let's say we have this slope here. I'm just going to draw a picture for myself. And now I'm going to draw the person. There's the skier. And I'm going to have the weight, the normal force. And they are saying that this man is going from rest and is going down. So that's the direction in which he's going to move. He starts, the initial velocity with which he starts from the slope is 0. He reaches a final velocity of 15 meters per second. That's at the end of the slope. I'm just putting in all the information, and they talk about a friction force. So there is a friction force. What we need to remember, can you remember when we did the slope, is when I work out all the forces that are parallel to the slope, never forget about FG parallel. Okay, we don't draw it in when we draw a free body diagram, but we have to remember it when we do the sum. Okay. Now, the first question is to work out the normal force. So if we have to work out the normal, can you remember the normal is equal to Fg perpendicular. So I'm going to write normal equals to Fg perpendicular, and you have to remember the equation for Fg perpendicular, which is mg cos theta. Okay, so that is what we're going to do there. So now, when we change that, when we substitute in what we need to substitute in here, we're going to do the following. We're going to say the mass of this person is 60 kilogram times the 9,8 times cos, and they said the slope make an angle of 15 degrees with the horizontal. So that's the angle that we're going to use, which is the 15 there. Okay, so when we work this out, we get an answer of 60 times the 9,8 and then cos 15, and the answer is 567,96 newtons. That would be the normal force that we're going to use. Okay, so the next one that we're going to look at is at 3.2.2. They say draw a labeled forces diagram. Diagram of all the forces acting on the man as he moves down the slope. Now here the picture that I drew was just for myself. Now if they want a real forces diagram, if they ask a forces diagram, you must actually draw it from a block. Okay. Even though in grade 12, when you look at the memos that they ask, most of the time they use a dot from where we draw it. Okay. So if they ask the forces diagram, free body diagram, I prefer you use a dot to draw it from. Okay. So the first thing that we're going to show is the weight. Okay. So that's the gravitation force. Then we have the N for the normal force. And the only other force that we know of is the friction force. We don't put in Fg parallel or Fg perpendicular. And the reason why we don't put it in, because we have the weight in. Okay, so either you put the two components in or you put the gravitation force in. So that one must be able to count 3 marks. Can you see? If they ask you to draw a labeled free body diagram or forces diagram, if it counts 3, it's 3 forces that you have to show. If it counts 5, it's 5 forces. So remember, look at the marks allocated for that question, and then you will be able to do that. Okay. The next question is to determine the average friction force that works on the man as he moves down the slope. So now they want us to work out this friction force. Okay. So again, what I'm going to do is I'm going to start with Newton's second law. So I'm going to say F net equals to M times A. Okay. Now, of course, this person is accelerating because he starts with the initial velocity of 0. He ends with a final velocity of 15. Okay. And we have the distance that he is going. The slope's distance is 75 meters long. Okay. Right. So we actually have the acceleration. So I'm first going to write it. We have the mass. We can work out the acceleration with the information given to us. Okay. Then we're going to say equal to. And what do we use? We use the front force minus the back force. Now this object is going in this direction. Okay. So the front force is then this one. Okay. So not drawn on my free body diagram, but the front force is going to be Fg parallel. So the moment when you get a slope, please do not forget about Fg parallel. And then what do they want us to work out? They want us to work out the friction force. And if we have to work out a force, we have to prove the direction in which the force is as well. So therefore, for the friction force, I'm just going to say plus friction. I'm not going to choose the direction here because I don't have the friction force. I have to prove that the friction force is opposing the direction in which the object is moving. Okay, so that's the first time when you have to work out friction, you don't say minus. Okay, you just say plus, because now I know I must get at the end the answer as negative, because the friction force must oppose the direction which the object is moving. Right. Now let's quickly look at this. First thing that I can substitute in is the mass of this person, and the mass is 60 kilograms. So I'm going to put in 60. Now I have a problem with the acceleration. And on your information sheet that they're going to give you, even though you did this last year, they give you the equations of motion. And this is what you need to remember. Now, when we work with the equations of motion, we can say that we have the initial velocity, that is 0. We have the final velocity, which is 15. And we have delta x, which is the distance or the length of the slope, which is 75 meters. Now you go to your information sheet and look at the equations of motion to work out acceleration, because I cannot work the sum out if I don't have the acceleration at this stage. Okay, so what I'm going to do is I'm going to say V final square equals to V initial square plus 2a delta y. That's the equation of motion that I can choose. They can ask you this question. This is why I put in this paper, because this is a paper that the grade 11s wrote at the end of the year. So let's quickly look at this. They say 15 is the final velocity. Initial velocity is 0 plus 2 times, I want the a, and the distance is 75. So when I work this out, I'm going to get an acceleration of 1,5 meters per second square. Now, I don't have to give a direction in this case. The only thing that I need to do here is to get a magnitude for the acceleration. Okay. This object or the person that is skiing is going faster. Therefore, I get a positive answer for the acceleration. So it's 1,5. Okay, equals to FG parallel equals to mg sine theta. And then I want to work out the friction force. Okay, let's substitute in 60 times 1.5 equals to 60 times 9,8 sine, and the slope that we use has a 15-degree slope plus friction. And then when we work it out, we get the answer. And the answer that we get for friction is going to be negative. You can go and work it out. So if you take that 60 times 1.5, let's just do that in between step. 60 times 1.5, I get an answer of 90. So I'm just going to write it in there, 90. And then if I use 60 times 9,8 times sine 15, I get an answer of 152,18559, for instance. When I take it over, it is 90 minus this answer. 90 minus the answer, and then you get an answer of minus 62,119 actually, 62,19 that you're going to get for your answer. All right, so the answer is minus 62,19. Remember, if I take this over there, this one, no, this one stays a plus. Let's just change the way that I wrote it so that you can see it. Okay, so for instance, I'm leaving the friction force on that side. And if I take this one to that side, then I get the answer of minus 64. Let me just check, 62,19. 62,19 is the newtons. Therefore, friction force equals to 62,19 Newton, and that would be up the slope. And then you will get all your answers, all your marks. All right. Okay, the next question that we have there is, let's just go back. This one we did. This one, then they say, determine the average friction force. That's what we worked out, 7 marks. Now we're going to look at number C. They say 2 blocks, one with a mass of 10 kilograms, one with a mass of 4 kilograms, is in contact with each other on a frictionless horizontal surface. The blocks are moving at a constant velocity of 20 meters per second, as indicated in the diagram. The braking force, now that's a bad word. Now, it must actually, the force that it's going to stop the object from going with this constant velocity. So I would say the force that is going to decrease the velocity, or the friction force of 28 Newton, is applied to the 10 kilogram block. So it means that there's a force. This is the direction which the object is moving, and the force of 28 newtons is going to break these 2 blocks so that it can go slower. So I would rather use a friction force that's going to oppose the direction which the object is moving. I would say is 28 newtons. Determine 3.3.1, the magnitude of the acceleration of the system. Okay, now they said this object is moving at a constant velocity of 20 meters per second. And now when this force is applied, obviously this object are going to start to move slower. All right. So when the object starts to move slower, the only force that is working on this object at this stage, now what I see is the 28 Newton. So if I look at the forces, I can say F net, that's just for you to remember, equals to M times A. Okay, I want to know the acceleration, but the F net force is going to be the front force. The object is going in that direction. So it means the front force that is going to push it in that direction minus the back force. So in this case, there's no front force. Remember, someone could have taken these 2 blocks and just let it slide on an object. There's only a force on an object if there is a contact with it, either by a rope or if a person is pushing it. So there is no applied force at this stage. Okay. Now, when I look at that, the only force is the friction force. Therefore, the net force is going to be equal to the friction force. So the front force, there's no front force, minus the back force. Therefore, I have the friction. And the friction force is negative because it opposes the direction which the object is moving. So when I look at this one, I'm going to have the 2 objects together, which is 14, times the acceleration equals to negative 28. And remember, I'm going to get a negative acceleration. Why? Because these objects are moving slower. So I can say acceleration equals to negative 28 divided by 14 gives us 2 meters per second square. But remember, they want just the magnitude, so we don't have to give a direction. And we don't leave it as a negative. If they said just acceleration, then I would have said 2 meters per second to the left, or opposing the direction in which the object is going. But if they want the magnitude, we must say, therefore, A equals to 2 meters per second square. You must change it to a positive to get the magnitude at the end. Okay, so don't forget about that. Then for the next one, they want the magnitude of the resultant force acting on the 10 kilogram block in the horizontal direction. Okay. Now, if you look at this one, then we can actually say, remember, on the 10 kilogram block, it is accelerating or decelerating actually with 2 meters per second square. So if they want the resultant force or the net force only on the 10 kilogram block where it is decelerating, then we can say F net equals to M times A. The mass of this block is 10, but I have to substitute in minus 2. So I'm going to get a force of minus 20 Newton. So on the 10 kilogram block, we have a 20 Newton force, but this force is going to the left, opposing the block to go forward. Okay. Then 3.3.3, the force of the 4 kilogram block on the 10 kilogram block. So as this object is moving in that direction, I know the force that the 4 kilogram block has on the 10 kilogram block is going to be exactly the same as the force that the 10 kilogram block has on the 4 kilogram block. So when I work this out, let's just quickly go and check, because it's going to be almost the same as when I have a tension between the two, but now it's just a force. So let's go and check this. Right, the first thing is I'm going to look at the 4 kilogram block. Okay. When I look at the 4 kilogram block, the forces that is working on the 4 kilogram block is going to be, of course, the friction force that is opposing this one. And then with the friction force, the force that the 10 kilogram block has on the 4 kilogram block. So therefore, we have two forces to that direction, and then of course a normal and a weight. Okay, so that's the force that the 10 has on 4, and this is the friction force. When I look at the 10 kilogram block and I go and check, draw a free body diagram for that one, then I have a friction force, but then the force that the 4 kilogram block has on the 10 kilogram block, 4 on 10, is in the opposite direction. We know the friction force. Okay, they gave it, they said it's 28. So if I start with Newton's second law for this one, equals to M times A. So I'm going to say M times A, there's no front force, there's only a friction force and a force that the 10 has on the 4. And this is the one that I want to work out. So the mass is 4 kilograms, acceleration is minus 2, and then the friction force is then minus 28, and then I want to know what is this one on this one. So then I can work out the force that the 10 kilogram block has on the 4 kilogram block. So it's 4 times 2 is 8. So it's minus 8 minus 28 plus 28, because I take it over, equals to negative. That's a force. So we're going to get a force of 20 newtons to the left. Okay, now let's look at this one, for instance. F net equals to M times A. So M times A equals to the force that the 4 kilogram has on the 10 kilogram block, plus minus the friction then, of course. And now when we look at this one, we're going to say 10 times the acceleration is minus 2. And then the force that it applies is the one that we work out. On the system, the, the friction force is 28. So then it's 20. This one is 10 times 2 is minus 20 plus 28. Okay, and then we get applied force of 18 kilograms. Okay, 8 newtons, sorry. This would be 8 newtons. So that is the force that it has. So in this case, we must remember the mass plays a role. So this would be your answer at the end. Okay, 8 kilogram. All right, let's look at the next one. Okay, that is the Newton's gravitational law. So let's just go back to this one. Newton's universal gravitational law, you have to know. So you have to know the definitions of Newton 1, 2, and 3, as well as Newton's gravitational law. Okay. Main thing about Newton's gravitational law, if we just look at that, the equation that we're looking at is F equals to G m1 m2 over r squared. G is a constant, This is the mass of the two objects, and this is the distance between the two objects. Distance must always be in meters. Mass must always be in kilograms. So don't get confused between these two. Distance must be in meters. Mass must be in kilograms. And then you have the gravitation constant, which is a constant that they will give us on the information sheet. This equation tells us Newton's gravitational law. So the definition for Newton's gravitational law is as follows. Any two objects in a universe attract each other with a force that is directly proportional to the product of their masses. Force directly proportional to mass 1 times mass 2, and inverted proportional to the square of the distance between the centers. So if you know the equation or you see the equation on your information sheet, you are able to give the law. So the force is directly proportional to the product of the masses between two objects, and the square of the distance, and inverted proportional to the square of the distance between the two centers. Okay. So the first one that we're going to use is the relationship between force and mass. That relationship is directly proportional. Directly proportional is a straight line through the origin. So say, for instance, they are going to say the distance between the two stays the same, but what's going to happen to the force if the two masses double? So we know we're going to use M1, M2, and if the two masses double, then I just put in a 2 and a 2. So the force is going to be 4 times greater. Okay. If the one mass double and the other one stay the same, then I have 1 times 2. So the force is going to be 2 times greater. If I look at this one, the one is 3 times greater, the other one is 1. So it's 1 times 3. So the force is going to be 3 times greater. Okay. The next one that we're going to look at is the relationship between the force and the distance. Now, I showed you at the beginning an inverted proportional relationship will be F is 1 over R square, as you can see it there. So I have a hyperbole as my graph. Okay. Now, this means the further the two objects away from each other, the smaller the force. Now let's see how we're going to work that out. So we know the equation is M1, M2. I'm just working with the directly proportional. They say the masses remain the same, but let's say the distance is double. So I put a 2 instead of a 1 for R. So it's 1 over 4. So it's going to be a quarter of what it was. And this is examples of it. If the distance is double, the force is going to be a quarter. If the distance is a half, the force is going to be 4 times greater. If the distance is double, what's going to be, and the masses are double, then the force is going to remain the same. So this is the one type of sum that you need to remember that you must use. So the two equations that you will get on the information sheet is this two. This one is the Newton's gravitational law. This one here is a directly proportional sign, and we use this one where they don't give us any values. So let's write there, no values. So if there's no values, they just say the one is 1 times greater, the other one is 3 times smaller, or so. Then we use this equation, okay? If there is values, we have two objects, so most of the time, 99, let's say 80% of the time, we're going to use this equation. We have two objects, the Earth and the Moon, or the Earth and the satellite. We have a distance between them. They want you to work out the forces. The last equation that I have is this one, which is also on your information sheet. And we use this equation when I only have one object. There's the Earth. Okay. They give us the radius of the Earth. They want you to work out the mass or the gravitation acceleration or so. So times one object, they only talk about one object. There's no other object. They want to ask about that one object. then you use the bottom one. The one on the right-hand top on the right-hand side, two objects, the Earth and a satellite or so, then you use that one. Now let's see if we put this to the, we do some examples. 4.1 here, number D. They say, each particle in the universe attract every other particle with force that is directly proportional to the product of their masses and inverted proportional to the square of the distance between the centers. So immediately, I must know, they just gave me Newton's gravitational law. Okay, so that is Newton's gravitational law. Right. The next one, the gravitation force between the two objects is F. That's the force. If the following takes place, what will the force be? If M1 is double, now can you see, this is what I just explained to you. Now they say the one is double, or both masses are double, or the distance is a half, or so. Then you use that first equation where you use the directly proportional one. So let's quickly look at that. Okay, so there's the two objects, all right? I'm going to say F is directly proportional, M1, M2 over R square, right? So they just say M1 is double. If they don't say anything about the others, then it stays 1. So M1 is double, so I'm going to use a 2 there. This one is a 1. The distance between the two remains the same. So what's going to happen to the force? The force is going to be 2 times greater. Okay, so you're going to say force is going to be times 2. Okay. Both masses are double. Again, what you do is you use this, M1, M2 over R squared. They didn't say anything about the radius. So 2 times greater, double over 1. So it's going to be 4. So the force is going to be times 4. So 4F. And this one is 2F. Okay. And then the distance R and the mass of it is mass of is half, and the mass is half. Nah. Okay, right. Let's look at this one. So we say F. Right. Let's just read there again. The distance R and the mass of, let's say, 2 of them is double. Is a half. So let's put in a half. The masses is a half. This one is a half, and the distance is a half. Okay, now let's look at that. So we get a fourth over a fourth. Now, so when I take it over, it's going to be a fourth, and when I swap it around, it's going to happen like this. So what's going to happen? The force are going to remain the same. So it's just going to be 1F. Okay. On the next page, it's number E. Let's quickly look at number E. Here they say, an alien flies in a flying saucer towards the Earth. The table indicates the magnitude of the gravitational force on the alien as determined at a certain point in his flight. Okay, so they give us the force at a certain point where that a certain flying saucer is. At what point is the alien the furthest from the Earth? And then where is the weight half of what it was on the Earth? Okay. Now, if we look at the force, remember, if the distance increases, it means that the force will decrease because the force is inverted proportional to the distance. So where is it the further away from the Earth is where the distance increase, so the force is going to decrease. So where's the force the smallest? At point F, as you can see it there. So that's where the force is the smallest, at point F. Then the weight is half of what it was on Earth. So where's the weight going to be half? Now we can say, right, weight is measured in newtons. Okay. Now if we look at this one, where it is the furthest away is at 100. Okay. And where it is the closest to the Earth is at 400. Okay. So when we look at that one, we're going to say, where is the weight half on the Earth? Okay. So it flows towards the Earth. So this is the closest, and this is the furthest away. Where it's halfway, it will be at E, which is 200. Okay. Right. The next one is 4.3, number F. Let me just see there, 4.3. Yeah, okay, now I have it. A skydiver with a mass of 78 kilograms is falling out of a plane at a skydiver is falling out of a plane at a height of 800 meters, 8,000 meters above the surface of the Earth. Determine the weight of the skydiver. Remember, weight is the same as the gravitational force, which is m times g. What is the mass? Mass of the person is 78 times 9,8. And 78 times 9,8 will give us an answer of 62,4 newtons. Okay, that would be the answer. 62,4 newtons. The next one, they say, name 2 factors that influence the weight of the skydiver. Okay, what is going to influence the weight of the skydiver? Number 1, the mass of the Earth, and number 2, distance that this skydiver is from the Earth. Yes.
Ma'am, 78 times 9.8 is not 62.
Okay, I thought it was. What is your answer?
Here I got 764,4.
Okay, thank you. I thought so. Let's just make this right. So it's 764,4 newtons. Okay, 40 newtons. Nah, thank you very much. Okay, so that's the weight of the person on Earth. Yeah, of course, it can't be 64. All right. Then they say, name 2 factors that influence the weight of the skydiver. So the weight is the force that the Earth have on this person. Remember, weight and mass is 2 different things. If my mass, if I get on a scale and the scale says 150 kilograms, then the mass is going to be the same on Earth, on Mars, on the moon, everywhere. My mass is going to be 150 kilograms. But my weight can change because the weight is determined by the planet that you are there, the gravitation acceleration of the planet. Now, in this case, this skydiver is on Earth. What's going to determine the weight of the skydiver? Number 1 is the mass of the planet, so the mass of the Earth. And number 2 is the distance that this person is above the Earth. So on a mountain, your weight is going to be different than on Earth, on the surface of the Earth, on the lowest point on Earth. But your mass, the kilograms, will remain the same. Okay. Now, the next one, they say, name the law that you use to answer question 4.3.2. And when we look at that law, remember 4.3.2 is where we have the weight, and that law is going to be Newton's gravitational law. I just want to make sure here. Let me just get my file here in order. Newton's universal gravitational law. Then the next one is state whether the acceleration of the skydiver is smaller, equal, or larger than the gravitation acceleration, and give a reason for your answer. Okay. Now, when we look at this one, on skydiver is larger, that's 4 marks. Give a reason for your answer. So that's the mass of the Earth. And then at 4.3, it's going to be, they say, state whether the acceleration of the skydiver is smaller, equal, or larger than the gravitation acceleration. Give a reason for your answer. Now, it's going to be smaller. Why? Because the gravitation acceleration is applicable if there's no other external forces. Okay. But when a skydiver is going to jump, there's going to be wind resistance. There's going to be all the other type of resistance that's going to make the gravitation acceleration smaller. That's in our real life. But if there was no wind resistance or anything, then the gravitation acceleration of this skydiver will be 9.8 meters per second square. Right. Then they say at number G, this is a new question, use the diagram below to answer the questions. The diagram is not drawn according to scale. Okay. This one they like to ask. They ask it in this test, and I saw it in a lot of other tests as well, because you have to think a bit further now. They say determine the magnitude of the gravitation force between the Earth and the Sun at the position in the diagram. They want us to determine the force between the Sun and the Earth. Okay. Two objects, Newton's gravitational law. So I use F equals to G M1 M2 over R square. They want us to work out the force. We have G. G is a constant, which is 6,67 times 10 to the power of minus 11. That's the constant. And then we have the mass of the Earth and the mass of the Moon. There they give it to us on the picture. Now you have to remember, and please remember that the radius of the Earth, the mass of the Earth, all the things that you want to know about the Earth is on your information sheet. So don't forget, if they ask you something about the Earth and you need the mass, go and check on your information sheet that they will give you. But in this case, we get the big G from the information sheet. The mass of the Sun is 1,99 times 10 to the power of 30. And the mass of the Earth is 5,98 times 10 to the power of 24. Mass must be in kilograms. So therefore, this is right. Now we have a problem. We don't have the distance from the Earth to the Sun. Okay. But what we have is we have the distance from the Sun to the Moon, and we have the distance from the Moon to the Earth. So we have this distance, and we have this distance, and it's a 90-degree triangle. So it means that's why it's going to count 6 marks. It means that I have to use Pythagoras to get the distance between the Sun and the Earth. So when I work this out, I'm going to say, let's say the radius square equals to the distance between the Sun and the Moon, SM, square plus the distance between MA. You can have your own equation there. So the distance between the Sun and the Moon is 2 times 10 to the power of 11, 2 times 10 to the power of 11, and then the square root plus from the Moon to the Earth. What's that distance? 4 times 10 to the power of 10, 4 times 10 to the power of 8. Square. Square root of that will give us the radius. Okay. Now let me just draw a line there. Okay. Now the radius that you're going to get there, let's quickly work it out, because I only have the final answer here, is 2 exponent 11 square plus 4 exponent 8 square. And then the answer is going to be 6,4 times 10 to the power of 39 newtons. Okay, that's the answer. Okay, no, and then the square root of this answer. Okay, so 6 square root of 6.4. So let's do this, square root, and then R is going to be 6.4 exponent 39, get an answer of 8 times 10 to the power of 19. Okay, so 8 times 10 to the power of 19. And remember, the formula says to the power of 2. Now, let's work that out. And you must be able to work it out with your calculator. Sometimes the learner struggles to do this with a calculator, so I want you to put it in your calculator. Make sure that you get this right. Eight exponent 19 to the power of 2. Answer. I got an answer of. And then you can put in ENG to get the engineering for that. And then you will get your answer. Let's just work this out again. So I get 2 exponent 11 to the power of 2, because I think this plus 4 exponent 8. Is dit 8 maal 10 tot die mag het jy hom uitgewerk? So it's 2, let me just see again. Square root 2 exponent 11 plus, you see, 4 exponent 8. Okay, just check. This one is not correct. Quickly check it. 2 exponent 11 to the power of 2 plus 4 exponent 10 to the power of 2 equals square root of the answer equals. Yeah, this one is not correct. That's the problem. So the answer, just check, is 2 times 10 to the power of 11. That's better. Okay, now let's see. 6.7 exponent minus 11 times 1.99 exponent 30 times 5.98 exponent 24 divide by 2 exponent 11 to the power of 2. Answer, that's better. 1,98 times 10 to the power of 22 newtons. That's better. Okay, so that's your answer. And then for the next one, next question that they ask. Oh my goodness. Next question that they ask is still there. Here they say the acceleration because of the gravitational force of the moon when the radius of the moon is 1,6 times 10 to the power of 6. Now can you see they want the acceleration on the moon if the radius of the moon is this. So they just talk about the moon. Okay. And we have the mass of the moon because they gave it to us. So the moment when we only have one object, we use this equation. Right. They want us to work out the acceleration. 6.67 times 10 to the power of minus 11 times the mass of the moon. Now let's quickly go and check. The mass of the moon is 7.35 times 10 to the power of 22. 7.35 times 10 to the power of 22. And then divide by, and then they gave us the radius in the question. And they said the radius is 1,6 times 10 to the power of 6. So 1,6 times 10 to the power of 6 to the power of 2. Don't forget about that square. When we work that out, we get a gravitation acceleration on the moon of 1,92 meters per second square. Okay, that's what we get for that one. Okay, so when you work it out, you're supposed to get that. And that is why we cannot walk on the moon now, because the gravitation acceleration is then different. Okay. Then what I have is a few multiple choice questions that I put on, because I know that normally that's one of the questions that, that we as teachers don't get time to do with you, but that's also the questions that you normally will struggle with when we do this. Now let's look at the first one, 1.1. Here they say, the result vector R and P is. Okay, Now look at that. They want us to get the resultant of these two. Now when I look at P, can you see it's two values to the left? And if I look at the X and the Y component of R, X component is 2 to the right and 2 upwards. So actually the resultant, because this is 2 to the left, 2 to the right, this 2 is going to cancel out. So the resultant of these two forces is going to be two values just
Up.
upward, north. Okay, so remember, and this is so your answer is going to be C. But I want you to remember that if I have two, let's say forces. Let's say I have a force of 2 newtons and a force of 7 newtons. That's the two forces that I have. Then a possible resultant of these two forces will be between, and then I can add the two. 7 plus 2 is 9, and I can minus the 2. 7 minus 2 is 5. So anything, any resultant between 5 and 9, any value between 5 and 9 is a possible resultant for these two forces. They like to ask that as a multiple choice question as well. Let's say they have two forces. The one is 8 Newton and the other one is 16 Newton. If we minus the two, a possible resultant will be from 8 to 24. Okay, now the reason for that is if I minus the 2, that's the minimum resultant force that I will get. And if I plus the 2, that's the maximum resultant. So if they are going to do like this, then I minus the 2 to get the resultant. But if they are in the same direction, then I add the 2 to get the maximum resultant. So it's just for you to remember that. Okay. 1.2, the diagram indicates a flower pot with a weight of 40 newtons that hang on a light string supported connected to A and a C with a light cable and B against the wall. Okay. Which one of the following statements are true about the forces in this case? Okay. Now, the tension force in the cable is BC is 40. The force exerted at point A must be 40. Remember the mass of this pot is 40. So if I draw the free body diagram, this one is 40 newtons. That's not the mass, the weight actually. Then we have AC, and here we have BC. That's the forces that we have. Okay. So if we complete the triangle, it's going to be this one downwards, then this one, let's say that one, and then this one. That's the triangle that we're going to draw. Okay. Now, because it's an equilibrium, then I can draw a triangle of forces. Now, they say the tension in the cable is 40, and then they go on, and then they say the vector sum of the tension in BC and the weight must be 0. And that's true. Okay. So the weight is the downwards one. Oh, my goodness. All right. The weight is the one that goes down. So this one is the weight, and that is the y component of BC. So in this case, we're going to say the vector sum of all the forces working on C must be 0. That's right. And then the vector sum of the tension in BC and the weight must be 0. But it's not the vector sum in BC. It's the y component of BC. This one. The y component of BC is going to be the same as the weight. So it can't be C, it must be D, because it's a closed triangle, therefore the total or the net force is going to be 0. Okay. Then all the forces are in equilibrium. The child sitting on a swing, the mother pulls the seat, and then of the swing horizontal to the left as indicated. In the diagram, which one of the following diagrams indicate the force that is working on the seat at the stage of movement? So the moment when she pulls the swing. And it can only be, so actually what they want us is to recognize the correct forces diagram, which is going to be number C. I think that one was one of the more easier ones. 1.6, a ball falls on a cement floor and bounces back up from the floor to the same height as where it fell. Which one of the following laws explain the best why the ball experiences an upwards force? Now for this one, it's going to be Newton's third law. Because the ball experiences a force on the floor experiences the same force just in the opposite direction on the ball. Okay, if it goes on to the same height. 1.7, a boy standing on a scale in a lift. Okay, the scale has a reading of 588 newtons when the lift is standing still. But if the lift starts to move, at which stage of his movement will the scale register a reading of 600 Newton? Which one of the following describe the movement of the lift at the point correct? Okay. Now, remember that is inertia of the body. If I stand on the scale and the, what do you call it, the lift is going upwards, I still want to be there down. So my body is going to go downwards. So the reading on the scale will increase. So in this case, what we can say is then number A, the lift is going to accelerate upwards. That's why when you're standing in a lift and the lift starts to move up, it feels as if your whole body wants to stay there. So, and it is what is happening because of inertia, the scale reading is going to increase. But when you're in the lift goes down, then it means your body still wants to stay there. So then the scale reading will decrease. So I will be able to stand on a scale in a lift when it goes downwards so that the newtons will be less. Nah. But I know for the boys, it's the other way around. You want to gain weight. Okay. That's just a joke. All right. I will see you then next week, Monday, with electricity. Please don't miss the electricity and electrostatics because some of you already did it, some didn't do it. So I'm going to start from the top there. And the themes that I'm doing here with you, this is what you need for grade 12. So we're doing the most important work that you need for grade 12. I hope that I helped you during this lesson. I will see you Monday again. Take care. Goodbye.